If you look back at our recent deep dive on the ghost GDP trap.
Right, the white-collar AI displacement.
Exactly. You might remember the central, rather unsettling thesis we uncovered there. We tracked how artificial intelligence had quietly, almost invisibly, begun just entirely hollowing out the white-collar middle class.
It was a massive shock to the system.
It really was. We watched the data show, copywriters, data analysts, administrative managers, mid-level consultants suddenly finding their highly paid screen-based skills being replicated by language models.
By algorithms.
Yeah, literally overnight in some cases.
But what was truly fascinating about that period, and what serves as the launch pad for what we are diving into today, is how the broader market reacted to that shock. And society at large, really. We saw what you could call the dumb money, watch that white-collar displacement happen, and they collectively breathed this massive sigh of relief regarding the physical world.
Oh, totally. The prevailing wisdom became this sort of comforting cultural mantra. Yes, people were constantly saying, well, at least physical jobs are safe. You can't code a plumber.
Right. You can't code a warehouse worker.
You can't code a forklift driver. It became this deeply held assumption that physical labor, the tangible manipulation of the real world, was the ultimate, impenetrable moat against the AI revolution.
It was a fascinating psychological firewall to observe. I mean, people built this mental barrier around the idea of tangible labor. The assumption was entirely based on the premise that, sure, the digital world could be automated because it's just moving pixels and restructuring data, but the physical world, that requires human dexterity. It requires human presence.
Human adaptability to chaos, right?
Exactly. Adaptability to chaos. But looking at it from a macroeconomic perspective, that assumption completely ignored the historical trajectory of capital. I mean, when institutional capital sees an efficiency gain in one sector, like what AI did to digital workflows, it doesn't just stop. It doesn't pat itself on the back and rest.
No, it immediately begins looking for the next structural barrier to break down.
Exactly. The intelligence that was cultivated and refined in the digital realm was inevitably going to be transplanted into the physical realm. It was never a matter of if, only a matter of when the unit economics would make it viable.
And that brings us perfectly to the core of today's deep dive, because the smart money knew that software, the algorithms that write emails and generate Python code, that was just phase one.
Phase one of a much larger transition.
Right. Phase two is already here. We are looking at a stack of sources today that are, frankly, mind-bending. The CEO of NVIDIA recently issued a stark warning that the ChatGPT moment for physical general robotics is just around the corner.
And here's the critical part, the foundation of our entire discussion today. According to the forensic macro analysis and the tech infrastructure production package we are unpacking, this isn't some futuristic sci-fi prediction slated for 2040 or 2050.
No.
It is a forensic reality happening right now in 2026.
Today we are opening the file on what our sources are calling the physical singularity.
The mission for our deep dive today is highly specific. We're going to decode the forensic data, proving that the profitability threshold for robotics has fundamentally been crossed.
Which changes everything.
It changes everything. We aren't dealing with theoretical prototypes in university labs anymore. Furthermore, we're going to expose the massive geopolitical forces, specifically what our sources call sovereign subsidies, that are actively and somewhat quietly driving this transition at a national level.
And finally, and perhaps most importantly for you listening, we are going to break down the exact four-part pick-and-shovel ETF playbook that institutional capital is using right now to navigate and profit from this monumental shift.
Because you have to know how to position yourself.
You really do. The tone of this material is intense, and frankly, it should be. The goal of this deep dive is to show you how to capture a massive, once-in-a-decade wealth transfer before humanoid robots become an everyday, mundane economic reality. We want to ensure you have the tools to be on the right side of this equation. Okay, let's unpack this. Let's start with the paradigm shift in unit economics. Because for the longest time, the idea of a general-purpose robot doing physical labor was kind of a running joke, wasn't it?
Oh, it was a huge joke.
I think back to those viral videos from the DARPA Robotics Challenge around 2015.
Yes, the ones where they would try to open a door and just collapse.
Exactly. You had these multi-million-dollar machines built by literally the smartest engineers on Earth, taking one step, slipping on a doorknob, and just dramatically falling over backward. The math was terrible.
Completely unviable.
If a robot costs $5 million to build, requires a team of PhDs to maintain it, and still drops the box half the time, it makes absolutely zero financial sense to replace a human worker earning a standard hourly wage.
You're hitting on the ultimate barrier there, unit economics. In macro analysis, we always look at unit economics, the direct revenues and costs associated with a single unit of a business, which in this context is a unit of labor. For decades, the unit economics of a human worker were vastly superior to a robot for general unstructured tasks. Think about a human. A human is highly adaptable, we are self-maintaining to a large degree, and crucially, we require no upfront, multi-million-dollar capital expenditure for an employer to begin utilizing our labor.
You just hire them. You simply pay them for their time and output.
Exactly. Robots, historically, were the exact opposite. They required massive upfront capital, constant specialized maintenance, and they could only perform rigidly defined, repetitive tasks in highly controlled environments.
Like welding a specific car door on an assembly line.
Yes, perfect example. If the environment changed even slightly, say a box was an inch to the left of where it was programmed to be, or the lighting changed, the robot failed completely. They were R&D money pits, completely unviable for general deployment.
But the sources we have today are screaming that this profitability threshold has officially flipped.
It has.
It's not just a gradual linear improvement, it's a phase change. The unit economics have inverted. So instead of being R&D money pits, general purpose, humanoid robots are turning into highly profitable corporate assets.
Which is why the capital is flooding in.
But I want to play devil's advocate for a second. It's easy to say the math is flipped, but where is the hard proof? What does this exponential scale actually look like out in the physical world?
That is exactly where the data becomes staggering. This is the ChatGPT moment applied to metal and motors, and we can track it through physical deployment metrics. Let's look at the first major data point from our forensic file. Waymo.
Okay, the autonomous driving company.
Right. Now, autonomous driving is arguably the most complex physical robotics challenge we've ever tackled because the environment, a city street, is pure chaos.
Pedestrians, weather, construction.
Exactly. Pure unstructured chaos.
Yeah.
In 2023, Waymo driverless cars were executing roughly 10,000 rides a week.
Which, to be fair, 10,000 rides without a human driver is an impressive pilot program. But in the grand scheme of a major city's transit system, it's a drop in the bucket.
It is. It was a successful proof of concept. But look at what happened by late 2025. That number didn't just double. It didn't triple.
What did it do?
It exploded by 45x.
45 times.
45 times to 450,000 driverless rides a week.
Wow.
We really need to pause and reflect on the sheer velocity of that metric, because a 45x growth rate in digital software, that's impressive, but it's fundamentally achievable because distributing software has zero marginal cost. You just send code over the internet.
You just spin up more AWS server.
Right. But a 45x growth metric in physical infrastructure, that is practically unheard of in modern industrial history.
Because to scale physically like that, you aren't just copying code. You are talking about building physical cars, establishing charging depots,
Scaling maintenance crews.
getting municipal regulatory approvals across different cities.
Precisely. To go from 10,000 to 450,000 physical rides means the underlying technology has moved entirely past the experimental phase. It has achieved operational reliability and profitability at scale.
The unit economics flipped.
Yes, it means the sensors, the real-time processing, the fleet management, and most importantly, the public trust and regulatory hurdles have aligned to allow exponential physical deployment. This isn't just a tech demo. It is a fundamental re-architecting of urban transportation happening in less than 3 years.
It's staggering when you think about the physical logistics required to scale like that. And it's not isolated to transportation. Let's flip it to the warehouse, because that's where the displacement narrative really hits home. Let's look at the second massive data point from the package. Amazon.
Prime example, pun intended.
Right. Back in 2019, Amazon had 200,000 robots. And honestly, back then, seeing those little Roomba-like Kiva robots sliding under shelves and moving them around, that was considered the absolute pinnacle of warehouse automation.
Everyone thought that was the finish line.
It felt like they had already won the automation race. What does that footprint look like today in 2026?
Today, they have over 1 million robots working in their warehouses.
1 million?
They added 800,000 robots in just a few short years. That is effectively a standing army of autonomous machines moving physical goods across the globe.
It's a localized
It
singularity.
really is.
Yeah.
But what is crucial to understand is that these aren't just the old blind robots following barcodes on the floor
These
anymore.
aren't just moving shells.
No, we are talking about highly advanced robotic arms that can identify, grasp, and sort entirely distinct unstructured objects. We're talking about autonomous mobile robots that navigate around human workers dynamically.
They can see.
Yes. When you look at 450,000 driverless rides a week and 1 million advanced warehouse robots, you realize the ChatGPT moment for physical robotics isn't coming. It's in the rearview mirror.
So how did they suddenly get so smart? For decades, they were clumsy. They were rigid. What is the anatomy of this singularity? Why do we cross this profitability threshold in this specific tight window of time between 2023 and 2026?
The answer lies in the convergence of two major technological streams that finally collided. First, artificial intelligence finally gave these robots a functional brain.
Okay.
Before the recent breakthroughs in what the industry calls spatial AI and large physical models, robots had to be hard-coded for every single microscopic movement. If you wanted a robot to pick up a mug, a programmer had to write lines of code dictating the exact spatial coordinates of the arm, the exact pressure of the grip.
Oh, wait, let's define that for a second. How is spatial AI different from the code that runs, say, my older robot vacuum at home?
Good question. Your older robot vacuum operates on highly simplified algorithms. It bumps into a wall, the physical switch is triggered, it turns 90 degrees, and moves forward.
Right, it's basically blind.
Completely blind. It doesn't actually know what a wall is. It just reacts to a triggered sensor. Spatial AI changes the paradigm entirely. It gives the robot a conceptual understanding of its physical environment in 3 dimensions.
So it actually understands the space it's in.
Exactly. Now, instead of hard-coding coordinates, the robot can learn by observing. It can generalize concepts. If the AI model knows how to pick up a ceramic coffee mug, it can infer the physics required to pick up a glass tumbler or a plastic cup.
Without a human programmer ever writing a new script for those specific objects.
Exactly. Because it understands the physics of gravity, friction, and spatial relations. That drastically reduces the cost of deployment. You don't need a team of engineers standing by to reprogram the machine every time the task changes slightly.
That makes total sense. The intelligence is no longer rigidly programmed. It's dynamically generated on the fly.
Right.
But a brain needs a body to enact its will. You can have the smartest spatial AI in the world, but if the physical arm is too slow or too weak, it doesn't matter.
And that's the second stream. The massive scaling of copper and semiconductor infrastructure, which we covered extensively during our recent supply crunch breakdown.
We did.
That infrastructure gave these robots a highly advanced nervous system. The proliferation of ultra-cheap, highly efficient sensors, advanced actuators, and specifically edge computing chips. That means the physical hardware finally caught up to the software.
Let's ground that term too, edge computing chips. Why is that a game changer for a physical robot?
Historically, to process complex AI, you had to send the data from the robot through the internet to a massive centralized cloud server, process it there, and send the instruction back.
Which takes time.
It introduces latency. And in the physical world, a half second of latency means a self-driving car crashes, or a robotic arm crushes a delicate package.
You can't have lag in the physical world.
Exactly. Edge computing puts the processing power directly on the edge of the network, literally inside the robot's own chassis. So you have an AI brain capable of complex spatial reasoning, communicating instantly across a nervous system of advanced semiconductors powered by high-capacity copper wiring. And it's executing physical tasks with a dexterity that was impossible 5 years ago.
It's all happening locally.
Yes, this synthesis is what fundamentally broke the unit economics. The cost of this advanced nervous system plummeted just as the capability of the AI brain skyrocketed.
It's the perfect storm. Hardware costs collapse while software capability goes exponential. And when you put those two curves together on a chart, the humanoid or general-purpose robot suddenly becomes cheaper than the human worker over a typical 5-year depreciation timeline.
The math becomes undeniable.
Because the R&D costs are amortized. The operational costs are fractions of a penny on the dollar for electricity. And the output is 24/7, without fatigue, without injury claims, and without shift changes.
What's fascinating here is that while the corporate profit motive, the drive of a company like Amazon to lower unit costs and increase operating margins, that is the most visible driver of this shift.
Yeah.
But it is really only half the story.
Okay.
If we zoom out and look at the forensic macro data provided in the package, we see that the true underlying catalyst for this explosion isn't just Jeff Bezos or Elon Musk trying to boost their quarterly earnings.
What is it?
The actual massive accelerator is geopolitical panic.
Geopolitical panic. That entirely changes the scope of what we are looking at.
It does.
We aren't just talking about corporate efficiency on a balance sheet anymore. We are talking about national security and global economic dominance. Let's dig into that. Is this just about who can manufacture the cheapest plastic goods?
No, it's about who controls the means of production for the next century. Our sources point directly to a massive, glaring disparity that is keeping policymakers awake at night. The China deficit.
The China deficit.
Right now, forensic analysis shows that China has deployed millions more industrial robots than the United States. And this wasn't some organic accident of the free market.
It was planned.
Heavily, aggressively subsidized by the Chinese government. They recognized years ago that their own demographic shifts, a rapidly aging population and a shrinking workforce, would eventually erode their status as the manufacturing floor of the world.
Because they just wouldn't have the people.
Exactly. To counter that demographic inevitability, they executed a state-mandated pivot toward total industrial automation. They are literally subsidizing the deployment of robots today to replace the human hands they objectively will not have in 20 years.
So the U.S. administration looks across the ocean, sees this massive, highly automated manufacturing base scaling up in China, and realizes that relying on cheap overseas human labor is no longer a viable long-term strategy.
It's a massive strategic vulnerability.
Right, because the global paradigm has shifted from cheap overseas human labor to cheap overseas robotic labor, which changes the dynamic entirely. And this brings us to what our sources call the ultimate sovereign subsidy. Because when you turn on the TV or watch a campaign rally or see a press conference, politicians are constantly promising one thing above all else.
We are going to bring manufacturing back to America.
Exactly. It's the ultimate political talking point.
It is a universally popular sentiment and, frankly, a vital national security objective. And I want to pause here because it is crucial for us, in this analysis, to remain strictly impartial. We are not endorsing or condemning either side of the political aisle or their specific legislative vehicles.
We are purely acting as forensic analysts, just looking at the data to understand the reality on the ground.
Exactly. And the forensic truth of this government policy, the reality behind the onshoring narrative, is profoundly complex and somewhat paradoxical. Well, the government is bringing the factories back to U.S. soil. The subsidies, the tax breaks, the tariffs, they are actively working to repatriate critical supply chains.
And it's working.
It is working, but, and this is the critical distinction that the public is largely missing, they are only bringing back a fraction of the jobs.
Here's where it gets really interesting, and honestly quite brutal when you look at the mechanics of it from the perspective of the American worker. The public is sold a very specific, nostalgic narrative.
The hard hats and lunch pails.
Yes. They picture bustling factory floors, thousands of American workers clocking in and out, revitalizing entire Rust Belt towns. But the sources we are looking at paint a completely different factory floor reality.
A very different reality.
Now, let's be accurate. While it's true that these newly repatriated factories aren't 100% workerless just yet, we aren't quite at the completely lights-out manufacturing stage where human presence is absolutely zero. The transition toward that reality is happening at breakneck speed. The sources provide a very specific, chilling example to illustrate this. Imagine a manufacturing plant that, historically, would have required 1,000 blue-collar workers to operate at full capacity.
A massive operation.
Right. Today, that exact same plant, newly built on U.S. soil with government incentives, only needs 50 workers.
From 1,000 down to 50.
Yes.
And we have to look closely at what those 50 workers are actually doing. Because they are not doing the physical assembly. They are not turning wrenches, welding joints, or moving pallets of materials.
What are they doing?
They are highly specialized technicians and software engineers whose sole job is to supervise the machines. They are holding tablets. They are there to maintain the robots, push software updates, and troubleshoot the automated lines if a spatial AI model encounters an edge case it can't resolve.
So the physical labor part is just gone.
Completely. The physical labor, the actual sweat equity of manufacturing has been entirely abstracted away from the human element.
Put yourself in the shoes of a factory manager in Ohio. If the government gives you a massive tax break to build a new facility, and the unit economics of robotics are now mathematically cheaper than human labor, You have a fiduciary duty to build the automated plant with 50 supervisors, not the legacy plant with 1,000 physical laborers.
You would be fired if you built the legacy plant.
Exactly. So 950 physical labor jobs are permanently gone from that specific economic equation. And the most intense part of this analysis is the funding mechanism behind it.
The sovereign subsidy.
Yes, the sources state that taxpayer dollars are actively funding this physical singularity. The U.S. government is pouring billions with a B into military autonomous tech, automated manufacturing grants, and R&D. Furthermore, they are providing massive tax incentives to the corporations that are building these highly automated factories.
Right.
The brutal irony here is inescapable. The working class, through their tax dollars, are essentially subsidizing their own rapid replacement.
It is a profound structural paradox. In order to remain geopolitically competitive with an automated China, the sovereign state must heavily incentivize its own domestic corporations to automate as quickly as possible.
Because if they don't, they lose the global race.
Exactly. So subsidies are designed to make building a multi-billion-dollar state-of-the-art robotic factory in Ohio more attractive to a CEO than building it overseas. But the byproduct of that necessary geopolitical maneuver is the structural displacement of the domestic blue-collar workforce.
It's unavoidable.
The government is caught in a trap where securing the national supply chain intrinsically means eliminating the jobs that historically sustain the middle class.
You can't separate the two. To win the geopolitical manufacturing war in 2026, you must utilize the most efficient labor possible. And the forensic data has proven beyond a shadow of a doubt that the most efficient labor is now robotics.
By a wide margin.
So, the sovereign subsidy is, in effect, a massive capital injection directly into the automation sector, publicly disguised as a traditional jobs program. It's a wealth transfer mechanism initiated by the state.
And this naturally transitions us to the speed of this economic change, because the velocity is what will catch most people off guard. If we connect this to the bigger picture, we can look at historical technological revolutions to understand the timeline we are facing.
Timelines are crucial here.
Right. Think about the internet. It fundamentally changed the global economy, but it took roughly 20 years to fully mature, from early consumer dial-up adoption to the total digital transformation of commerce and supply chains.
It was a long runway.
They gave society a generation to adapt, to learn new skills, to transition capital from brick and mortar to e-commerce.
Right, people had time to acclimate. You had time to learn how to use a computer, to transition your business from paper records to digital databases, to figure out how online marketing worked. It was a slope. You could see it coming. And you had a decade to adjust your career trajectory. It wasn't a cliff.
But then we look at the AI software revolution. ChatGPT hit the market, and it only took about 3 years to completely upend the white-collar labor market.
3 years.
3 years for the ghost GDP phenomenon we discussed previously to become a reality.
The acceleration is terrifying.
Exactly. The adoption cycles are compressing radically with every new paradigm. And now, applying that compression to the physical world, our forensic analysis projects that physical robotics will reshape the labor market before the decade ends.
Not 20 years.
We are not looking at a 20-year horizon. We are looking at a permanent displacement of millions of physical labor jobs within a handful of years. And as we noted with the factory example, the 1,000 workers reduced to 50, this massive displacement of physical labor is offset by only a relatively tiny number of highly specialized engineering and maintenance roles.
The math of job creation versus job destruction in this specific singularity just does not balance out for the average worker.
It is highly asymmetric.
It's an incredibly stark warning. And I want to address you, the listener, directly right now. If your income, your livelihood, relies entirely on selling your physical labor or your process-driven repetitive time, you are standing on the tracks.
The train is coming.
You are in the direct path of a macroeconomic freight train that is heavily subsidized by sovereign governments and driven by the smartest, most ruthless capital in the world. The writing is not just on the wall, it is in the forensic data. It's in the 45x growth metrics of Waymo. It's in the million robot standing armies of Amazon.
You cannot outwork a machine that does not sleep.
That does not ask for a raise, that does not form a union, and is functionally subsidized by the state to replace you.
The historical precedent here is crystal clear. When a technology crosses the profitability threshold and simultaneously receives sovereign backing for geopolitical reasons, it becomes an unstoppable force. Exactly. The only rational response for an individual or an entity navigating this economy is to shift their position relative to the capital. If you cannot sell your labor competitively because the unit economics have broken against you, you must own the infrastructure that is replacing that labor.
You have to transition from the labor side of the ledger to the capital side. Yes, the absolute necessity to pivot. You have to aggressively pivot your portfolio to own the infrastructure. Which brings us to the most actionable and arguably the most important part of our deep dive.
The playbook.
So, what does this all mean? How does the smart money actually profit from this? Because recognizing the trend is only half the battle. Executing a sound financial strategy to capture the wealth transfer is the other half.
The immediate instinct for many retail investors when they see a new technological boom, whether it was the early internet in the 90s, the electric vehicle craze of the 2010s, or now physical robotics, is to try and pick the winning brand.
They want to find the Apple or the Tesla of humanoid robots.
Exactly. They look for the flashy startup with the viral video of a robot doing backflips or making a cup of coffee, and they pour their capital into that single equity, hoping for 1,000% return.
And our sources explicitly warn against this. They call this the startup trap. The forensic data is brutal here. 90% of robotic startups will go bust.
It's a massive failure rate.
Building physical hardware at scale is incredibly difficult. It's insanely capital intensive and highly prone to catastrophic failure. It is entirely different from building a software app where your overhead is just server space and developer time.
Right.
Trying to pick the one brand that will dominate a nascent, highly competitive hardware market is essentially buying a lottery ticket, and the smart money does not play the lottery.
Exactly. Instead of trying to pick the winning prospector, the smart money uses a strategy as old as the California gold rush, the pick and shovel playbook. During the gold rush, the vast majority of individual miners who went looking for gold went bust. They died broke. The people who consistently made fortunes were the ones selling the picks, the shovels, the tents, and the Levi's jeans to the miners.
The infrastructure.
They provided the indispensable infrastructure required for the gold rush to happen, regardless of who actually struck gold. In the context of the physical singularity, the smart money executes this playbook via ETFs, exchange-traded funds.
For those who might be unfamiliar, an ETF allows you to buy a basket of stocks in a specific sector rather than betting on a single company.
Right. This strategy allows them to own the broad capital layer, capturing the systemic growth of the entire industry without taking on the idiosyncratic risk of a single startup failing.
Let's break down this exact four-part ETF playbook detailed in the production package. This is how you shift from being the displaced labor to owning the capital. We are going to spend some real time here to make sure you understand the mechanics of each category. Category 1 is what the sources call broad automation, or the vanguard. The specific tickers mentioned here are BOTZ and ROBO. Let's unpack what these actually hold.
Let's dissect the mechanics of these funds. BOTZ and Robo are designed to give you broad, diversified exposure to dozens of companies across the entire robotics ecosystem.
Oh.
We aren't just talking about the companies building the shiny humanoid robots.
Right.
We are talking about the foundational components. These funds hold the companies building the highly precise mechanical arms used in auto manufacturing. They hold the firms developing the LiDAR sensors, the laser scanning systems that allow autonomous vehicles to see their environment in 3D.
The eyes of the robot.
Yes. They hold the software companies writing the spatial mapping algorithms we discussed earlier, and the massive industrial automation giants whose sole business is integrating these diverse systems into legacy factories to make them run efficiently.
So instead of betting that startup A will beat startup B in making a warehouse robot, you buy the basket that supplies the parts to both of them.
Exactly.
If the entire industry of physical automation grows, which our forensic data on Amazon and Waymo proves is happening exponentially, then the basket grows. You capture the macro trend. It's the simplest, most direct application of the pick and shovel theory to the robotics sector. It's foundational.
It's the baseline.
But let's bridge this to the geopolitical angle we covered, because the government is a massive player here.
And that leads directly to category 2, which is termed the defense ledger, or the blank check. The sources highlight tickers ITA and PPA. This category is where we see the sovereign subsidy and geopolitical panic materialized in the financial markets.
This is a crucial connection. We talked about how the government is pouring billions into military autonomous tech, while consumer robotics, like a robot cleaning your house or delivering your groceries, might face regulatory hurdles, municipal zoning laws, or consumer adoption friction.
Military spending operates on a completely different paradigm.
It does.
Precisely. Military spending is, for all intents and purposes, guaranteed capital. The Department of Defense does not operate on the same profit margin constraints or consumer interest rate sensitivities as a retail company.
They just need to win.
When national security is the mandate, and when you are trying to outpace a rival nation's automated military capabilities, the capital flows are massive. They are sustained. And they are largely immune to broader economic recessions.
Right.
ETFs like ITA and PPA capture the aerospace and defense contractors that are the direct recipients of these government blank checks. These are the legacy entities and specialized tech firms building autonomous drone swarms, automated logistics chains that can supply troops without risking human drivers, and next-generation robotic defense platforms.
So by owning these funds, you are directly capturing the billions of tax dollars being pumped into the militarized edge of the physical singularity.
It's a direct pipeline.
It's a stark realization, but from a purely investment standpoint, it is incredibly potent. You are aligning your portfolio with the most powerful, recession-proof, sovereign spending initiatives on the planet.
You're betting alongside the government.
Next, we have Category 3, industrial onshoring, or the tax subsidy. The source ticker here is XLI. This ties perfectly into the illusion of onshoring we discussed earlier.
The XLI ETF provides broad exposure to the industrial sector. This includes the massive aerospace, machinery, heavy equipment, and manufacturing giants. Think of your traditional American industrial titans.
The big legacy names.
Yes, these are the companies that are currently the primary beneficiaries of the government's tax incentives and tariffs designed to force supply chains back to U.S. soil.
Right.
They're the ones taking the massive state subsidies, building those sprawling new plants that require only 50 human supervisors instead of 1,000 physical workers, and dramatically increasing their operational margins as a result of that labor displacement.
So, by holding XLI, you are essentially buying a direct stake in the rapid, subsidized replacement of human labor across the traditional American industrial base.
You're profiting from the efficiency gains.
You are capturing the massive value generated when a legacy company uses government tax breaks to automate their entire supply chain, slashing their payroll while boosting their output. It's the financial capture of the policy we discussed. It's owning the factory that just fired 950 people and replaced them with machines.
It sounds harsh, but it's the financial reality. And finally, we arrive at what I consider the most critical layer of this entire analysis.
Right.
Category 4, the backbone, or the absolute necessity.
The foundational layer.
The ETFs highlighted here are SOXX, focusing on semiconductors, and DTCR, focusing on data centers. If there's a foundational pillar, an absolute physical constraint to this entire robotic revolution, this is it.
This is the non-negotiable infrastructure. As the source put it so clearly, robots are just metal without brains.
Just expensive paperweights.
Exactly. It doesn't matter if an American company builds the best robot, or a Chinese company, or a European company. It doesn't matter if the final form factor has 2 legs, 4 legs, or wheels. Regardless of which specific robot brand wins the physical singularity, they all share a universal, fundamental physical dependency.
They all require an astronomical amount of compute. In order for spatial AI to function, these machines need highly advanced semiconductors to process complex spatial data in real time, to execute localized algorithms, and to literally think on the edge.
The nervous system we talked about.
Yes. And beyond the chips inside the robots, the industry needs massive, hyperscale data centers to train those underlying AI models, to store their operational memories, and to facilitate communication across massive autonomous fleets.
So SOXX and DTCR cover that.
ETFs like SOXX capture the chip makers, the companies physically fabricating the silicon nervous system. And DTCR captures the digital real estate, the massive physical facilities consuming gigawatts of power to house the servers that act as the collective training ground and brain trust for these machines.
If the physical singularity happens, and the data says it already is, the demand for advanced chips and the power-hungry data centers that support them goes completely parabolic.
Parabolic.
It is the most insulated, high-probability bet in the entire playbook, because it sits underneath the entire robotics war. Every single new robot deployed by Amazon, every new autonomous car deployed by Waymo is a new node on the network demanding continuous silicon and data center resources.
When you synthesize these 4 categories, broad automation capturing mechanical growth and sensor integration, The defense ledger capturing guaranteed, recession-proof sovereign spending, industrial onshoring capturing the subsidized margin expansion of legacy titans, and the backbone capturing the non-negotiable compute and energy infrastructure.
You construct a highly comprehensive financial architecture.
Exactly. It is designed specifically to capture the wealth generated by the structural displacement of physical labor. You transition from being a passive observer, or worse, a displaced participant scrambling for relevance, to an owner of the underlying economic engine.
It is a brilliant, ruthless, and absolutely necessary playbook for navigating what is coming. Which brings us to our final verdict. We've laid out the forensic data showing the unit economics flipping. We've exposed the geopolitical forces and sovereign subsidies driving the speed of this transition. And we've walked through the granular details of the ETF strategy.
We covered a lot of ground.
We did. The core thesis we have extracted from these sources is undeniable. When money changes hands in a technological revolution of this magnitude, it inevitably flows from the hands of the workers to the vaults of the owners.
It always does.
The displacement is structural, it is permanent, and it is subsidized by the state.
We must also emphasize a critical caveat present in the sources, one that every listener must internalize. You must expect massive volatility in this sector.
It won't be a straight line up.
No. We're talking about the complete rewiring of global manufacturing, urban logistics, and the labor market. This will not be a smooth upward line on a chart. There will be massive supply chain disruptions as old systems fail.
There will be intense regulatory battles as unions and municipalities fight back.
There will be spectacular multi-billion-dollar corporate failures as companies bet on the wrong hardware. And there will be geopolitical shocks as nations vie for dominance over critical supply chains.
The path upward will be violently jagged.
Extremely jagged.
The volatility will be stomach-churning at times, but the key takeaway, the absolute imperative from our sources, is that while this sector will be highly volatile, avoiding it entirely is the greatest financial risk you can take in the 2020s.
You can't just ignore it.
If you sit on the sidelines out of fear or disbelief, you are mathematically guaranteed to lose your purchasing power relative to the massive efficiency gains of capital. The government is subsidizing the future of automation. Make sure you own a piece of it. So I have to ask you directly as you process all of this, which side of the transaction will you be on?
This raises an important question, one that moves beyond the factory floor, beyond the macroeconomic data, and directly into our daily lives. Based on the sheer velocity of everything we've discussed today, the 45x scaling in transportation, the unit economics flipping in real time, the massive sovereign investment driving hardware capabilities, do you believe humanoid robots will be doing household chores like laundry, cooking, and basic home maintenance within the next 5 years?
In 5 years? That's fast.
We are seeing the industrial deployment right now, but how fast does that capability bleed into consumer reality? It's a question of when, not if, the singularity crosses the threshold of your front door.
It's a fascinating, slightly unnerving thought to end on, but I want to add one final, purely source-derived extrapolation for you to mull over as we wrap up. We've established that this physical singularity requires the massive, non-negotiable infrastructure we just outlined. Millions of new robotic units, sprawling new hyperscale data centers, endless advanced semiconductors. But what happens when we hit severe physical bottlenecks? Our sources point to a critical issue: the exact physical commodities required to build this future. Specifically, they mention a massive looming copper deficit, what they refer to as the red gold rush.
Red gold rush.
Think about it. If every single one of these millions of robots needs extensive copper wiring for its nervous system to function, and every new gigawatt data center requires thousands of miles of heavy copper cable to draw power from the grid, who controls the copper?
That is the ultimate bottleneck.
If the bots literally need copper to function, the real bottleneck isn't the brilliance of the AI software, it's the raw earth. Consider the profound implications of that physical limit on the digital dream. We've unpacked a massive, world-altering paradigm shift today. Remember, the future belongs to the owners.